Dear students, our today's module is on programming concurrent activities. In the previous modules, we have practiced some very basic constructs of programming language, and we have also learned that imperative paradigm, the sequence of instructions flows in one by one. So first instruction is executed and then second and then next instruction. And we also discussed that if we want to control the flow, then we can use the control structures using if statement or using loop statement. However, today we will try to understand that sometimes we do not want to execute one code at once. Instead, we want to execute many different codes simultaneously. And such a phenomena is known as in computer science as parallel processing or concurrent processing. So, simultaneous execution of multiple activations is called parallel processing. So, let's have an example. So, this is one of the famous game nowadays with kids, and in this game you can see that there are many different icons and there are many different characters. So, if for example we have written a code which is executing or managing the instructions for this particular object, we say it as object 1, then until when this object's instructions are not finished, then object 2's instruction cannot be executed, object 3's instructions cannot be executed, and so on. So we want to process all of the activities of all of the objects on this screen simultaneously. So then you will get a feeling that this is a real game. If it happens in a way that only the statements of object 1 are executed first and all of the objects are standing idle, then you might not feel it like a realistic or real game. So actually the true parallel processing can be achieved if we have multiple processing units. So we execute one of the object's instructions on one core or one CPU or one processor, and the statements and the sequence of statements are bulk of statements that belong to the second object on the second core. So this is how we can achieve the true parallel processing. However, when we have only one CPU, as you can see that in our computers, whatever we use at our home or offices, so they do not have many CPUs and we cannot afford. So we have only one CPU, or we might have 2 or 4 CPUs, and then there are many objects or many concurrent activities which we want to perform. So such an implementation can be done using multi-programming, which we discussed some time ago. So the activations are basically the different methodologies and naming conventions are available in different programming languages. So in some of the programming languages it is called task, like in Ada language, and in Java it is called thread. So this means for executing concurrent activities in Java, you need to make many different threads belonging to the one task. So this means in the previous example, you need to make threads equal to the number of objects in the game. So each thread is consuming the CPU on its turn, as we have learned in multi-programming. So this is how it works. We make a central programming unit, and that central programming unit generates multiple threads or tasks in different languages. So for example, this has generated one piece of thread here and one piece of thread here. So both of the threads are now executed simultaneously, of course, on their own turn, if there is only one CPU. And if there are multiple CPUs, then they are being executed simultaneously without waiting for the second objects or thread. So if we summarize today's module, we have learned about concurrent processing and parallel processing, and we have discussed with a scenario that how it can be achieved and what is actually a true parallel processing, and how, if when we do not have multiple CPUs, then how we can convince the user that we are actually performing parallel processing using one CPU.